Immerse in the Dreamcraft galaxy, where technology dances with the human spirit. Here, the thrill of sports meets the edge of innovation, crafting dreams into reality. From the roar of engines to the cheer of the crowd, every beat pulses with passion. So gear up, strap in, and brace for a journey that transcends the playfield. This is the Dreamcraft galaxy, where the game never ends and the adventure is just beginning. Have you ever wondered how a machine can recognize your face? Or how your phone's voice assistant seems to understand exactly what you're saying? These everyday marvels are not merely feats of technological wizardry, but are the result of a complex and often misunderstood science, artificial intelligence, or AI. At the heart of this conundrum is a concept known as the AI neural network. It's inspired by the human brain and its billions of neurons, each processing and passing on information in a vast, interconnected web. But unlike our brains, with their organic unpredictability, AI neural networks operate with precise mathematical constructs. They weigh and bias inputs, transforming them into desired outputs. Just like a human child learning to walk, these networks learn through training, adapting their decision boundaries to perform complex tasks. This dazzling dance of numbers and algorithms is what empowers your phone to recognize your voice, or the security camera to identify your face. The answer to these wonders lies in the fascinating world of AI neural networks. So, what exactly are these AI neural networks? Let's start by painting a picture of neural networks. Imagine a bustling city, where roads are neural pathways and intersections are neurons, processing and transmitting information. AI neural networks are essentially interconnected layers of these artificial neurons or nodes. They're designed to imitate the human brain, allowing computers to learn from observational data. Each network consists of three main parts: the input layer, the hidden layers, and the output layer, each playing a crucial role in the learning process. The input layer is like the city's gateways, where all the raw data enters the neural network. This could be any form of data, from pixels of an image to the frequencies of a sound. It's the starting point of any neural network. Next, we have the hidden layers, the heart of the network. These are the bustling streets of our city, where all the heavy lifting takes place. Each hidden layer consists of numerous artificial neurons, each taking in data, processing it, and passing it on. The more hidden layers a network has, the more complex patterns it can recognize. It's in these layers where the magic of learning and understanding happens. Finally, we have the output layer, the final destination of our city. It's where all processed information converges and the network makes a decision. Whether it's recognizing a face in an image or understanding speech in a voice recording, the output layer is where the network presents its conclusion. And that's it. That's the basic structure of a neural network. But don't let its simplicity fool you. The true genius lies in the way these layers work together, learning and adapting to process complex data and make intelligent decisions. Think of it as an assembly line, working together to process information and produce a result. It's a beautiful symphony of artificial neurons, each playing its part to create the music of artificial intelligence. At the heart of these networks are artificial neurons, simple yet powerful. Picture, if you will, a tiny mathematical construct, a single cog in a vast, intricate machine. This is the artificial neuron, the fundamental building block of artificial intelligence. These artificial neurons are inspired by the biological neurons in our own brains. But instead of electrical impulses and chemical reactions, they use numbers, equations, and algorithms. Their function, however, remains similar. They take in input, process it, and produce an output. Let's break down this process. Firstly, the artificial neuron receives multiple inputs. These inputs could be anything: the pixels of an image, the words of a sentence, the notes of a song. Each input is assigned a weight, which determines its importance. Some inputs might be crucial, others might be irrelevant. Next, the neuron processes these inputs. It adds up all the input values, each multiplied by their respective weights. To this sum, it adds a bias, a sort of adjustable offset that helps the neuron make more accurate predictions. Finally, the neuron produces an output. It applies a function, known as an activation function, to the processed inputs. This function decides whether the neuron fires or not, much like a biological neuron. The output is then sent forward, either to be the final output of the network or to serve as an input to another neuron. This process might sound complex, but it's essentially just a series of simple mathematical operations: addition, multiplication, and function application. And yet, These simple operations give the artificial neuron a powerful ability, the ability to learn. By adjusting the weights and biases during training, the neuron can learn to transform any given input into a desired output. It can learn to recognize a cat in a picture, understand a spoken command, even compose a piece of music. Despite their simplicity, when these artificial neurons work together, they can accomplish complex tasks. They are the silent workers, the unsung heroes of artificial intelligence. And their simplicity is their greatest strength, for it allows them to adapt, to learn, and to solve problems in ways we could hardly imagine. But how do these networks learn to do tasks like recognizing your face or understanding your speech? Just as a child learns to walk, talk, and interact with the world, so too does a neural network learn to perform complex tasks. But the way it learns is quite unique, and it's all about training. Training is the process through which neural networks learn to transform input values into desired outputs. It's like teaching a dog to sit. You give a command, and if the dog sits, you reward it. If it doesn't, you correct it and try again. This is similar to how a neural network is trained. The network is given a set of inputs and the desired outputs. If it gets the output wrong, the network adjusts its weights and biases, the internal variables that determine how it processes inputs, until it gets closer to the correct answer. But here's where it gets interesting. These networks aren't just learning to match one input to one output. They're learning to create flexible decision boundaries. Imagine trying to separate a basket of red and green apples. You could draw a line down the middle, but what if the apples are mixed up? A straight line won't work. But if you could draw a line that curves and twists, you could separate the apples perfectly. That's what a neural network does. It learns to draw these complex, flexible boundaries that can accurately separate and classify inputs, no matter how mixed up they might be. What's more, the more data a network is trained on, the more accurate it becomes. It's like practicing a sport. The more you practice, the better you get. The same principle applies to neural networks. The more examples it has to learn from, the better it becomes at performing its task. This learning ability of neural networks is what makes them so powerful and versatile. They can learn to recognize faces, understand speech, drive cars, and even diagnose diseases, all by being trained on vast amounts of data. Training is the key that unlocks the potential of these networks, enabling them to perform complex tasks. Now you might be thinking, it all sounds simple enough, but where's the genius in all this? Well, let's delve deeper into the world of neural networks. The wonder of artificial intelligence lies not in the complexity of individual neurons, but in the intricacy of their connections. Picture a single neuron as a simple, humble worker. Alone, it can perform only basic tasks. But when you start linking these workers together, forming teams, departments, and entire organizations, you start to see the emergence of something much more sophisticated and capable. This is the essence of neural networks. By linking together multiple neurons, each with their own weights and biases, we form vast networks. These networks are capable of learning and performing tasks of such complexity that they can mimic and sometimes even surpass human abilities. From image recognition to natural language processing, the capacity of these networks is astounding, and yet it's all based on simple components. Each neuron, each connection, each weight and bias is a basic element, but when they come together, they form something far greater than the sum of their parts. This is the genius behind the simplicity. Think of it like a symphony orchestra. Each musician plays a simple part, but when combined, they create a complex, beautiful piece of music. Or consider a puzzle. Each piece is simple and meaningless on its own, but put them together, and you get a complete, detailed image. This is what neural networks do. They take simple components and transform them into complex systems. They allow us to take basic principles of computation and create systems that can learn, adapt, and perform tasks that once seemed the exclusive domain of human intelligence. So, the next time you marvel at the capabilities of AI, remember the humble neuron. Remember the simple weights and biases. Remember the basic components that, when combined, form the intricate neural networks that power the wonders of artificial intelligence. The true genius of AI neural networks lies in their ability to turn simplicity into complexity, to transform basic processes into extraordinary capabilities. So, what does all this mean for the future of AI? Well, the potential is immense. As we continue to unravel the intricacies of artificial neural networks, we open up a world of possibilities in various disciplines. In medicine, AI could revolutionize diagnostics and treatment plans. In environmental science, it could help predict climate trends with greater accuracy. The field of education could see personalized learning plans tailored to individual student needs. And let's not forget about business and industry, where AI can streamline operations and drive innovation. However, to harness this potential, we need a deep understanding of these networks. Training, learning, decision-making. These aren't just functions of an AI system. They're the building blocks of a future where artificial intelligence is not only a tool in our toolbox, but an integral part of our daily lives. In a world that spins faster every day, we're here to keep you in the loop. Dive into the ever-evolving realm of artificial intelligence with us. Be an integral part of this revolution. How? Subscribe, watch, share, ignite conversations, engage in the dialogue. Ready for this thrilling ride? Prepared to glimpse the future? If the answer is yes, press subscribe. Stay tuned, stay informed, and become an active participant in this exhilarating adventure.